Good wishes to all of you. Environment and Ecology, Chapter 2, Part 2, Ecological System, Biodiversity and Conservation. Chapter 2, Ecology and Ecosystems Audiobook. Keep up your spirits with this motivational quote. Success is the sum of small efforts repeated day in and day out. Robert Collier, 1885 to 1950, American author. Earth as an ecosystem stands out in the all of the universe. There is no place that we know about that can support life as we know it. Salvia Earle, 1935. American marine biologist, explorer, and author. How will this chapter help you in the examination? This chapter is important because many questions have appeared on the topic in the prelims. The topic is relevant more to prelims than to mains. Most of the text is a basic theory and hence static. You need to learn many definitions in this chapter. These explanations have been made as simple as possible and examples have also been given. Lead story. The Andaman and Nicobar Islands represent a vital ecosystem of India. The case has excellent potential for figuring in prelims and mains. What will you learn in this chapter? How do we define and describe an ecological system or ecosystem and its components? What are the structure and functions of an ecosystem? How do materials and energy move through an ecosystem? What is the state of its ecosystem? What are the keywords and phrases that you should remember? Abiotic conditions alleged Andaman and Nicobar Islands, aquatic life zone, atmosphere, autotroph, biochemical cycle, biome, biosphere, biota, carbon cycle, carnivore, cell respiration, climate ecosystem, commensalism, community, competition, consumer, decompositor, retriever, ecological balance, ecological efficiency, ecological niche, ecological pyramid, ecological succession, ecosystem, ecosystem service, ecosystem structure, ecotone, edge effect, energy flow, exosphere, food chain, food web, fungi, habitat, herbivore, heterotroph, home range, hydrosphere, ionosphere, lichen, lithosphere, mesosphere, moss, mutualism, nitrogen cycle, organism, partist, sorry, parasitism, Phosphorus Cycle, Photosynthesis, Population, Predation, Producer, Pyramid of Biomass, Pyramid of Energy Flow, Pyramid of Numbers, Respiration, Species, Stratosphere, Sulfur Cycle, Symbiosis, Thermosphere, Trophical Level, Troposphere, Water Cycle. Report Program Millennium Ecosystem Assessment UN Decade on Ecosystem Restoration. Lead story Andaman and Nicobar Islands, a rich ecosystem in peril. This is a story of a unique island ecosystem. Rampant deforestation, inward migration from the mainland, impact of developmental projects on tribal people and the environment, Supreme Court judgments, and continuing plunder of nature. The Andaman and Nicobar Islands in the Bay of Bengal is an archipelago of over 350 islands. It is of a great importance as an ecosystem due to its rich biodiversity. Scientists have found 250 species of birds, 85 reptiles, 60 mammals, and thousands of invertebrates and plants on these islands. More than 25% of the species are endemic to the area, that is, they are not found anywhere else in the world. The islands are known for their forests, mangroves, and coral reefs. Five ancient tribes, including the Jarvas, have been living on the islands for centuries. Today, the ecosystem is in deep trouble. Deforestation, which began during the British times, has never stopped, despite several areas being declared as reserves. People are cutting down mangroves and sediments are killing coral reefs. The government has encouraged inward migration, and the five tribes have become a small minority. They will probably go extinct soon. A significant reason for the ecological destruction and the plight of the tribes is the 340 kilometers long Andaman Trunk Road ATR, connecting the north and the south. The resultant traffic has destroyed some forests as well as the tribal's way of life. The tsunami of 2004 was another significant blow to the ecosystem and the people. The disaster damaged fertile land, destroyed mangroves and coral reefs, and killed 300 people and 150,000 cattle. Responding to public interest litigation, the Supreme Court passed several orders in 2002 ban on tree felling, a limit on migration, closure of ATR in tribal areas, and so on. But these orders have not been appropriately implemented, and the ecosystem continues to be under severe threat. The Global Environment Faculty is funding a project to address some of the issues. In 2020, Niti Aayog came out with a vision document, Sustainable Development of Little Andaman Island, a proposal to leverage the island's strategic location and natural features. The government will implement the play by building a new greenfield coastal city and a free trade zone to compete with Singapore and Hong Kong. There will be a financial district, a leisure zone, and a nature zone. Environmentalists are alarmed at this development because the proposal does not consider the ecological wealth and vulnerability of the Little Andaman Island. It was the worst affected island during the 2004 tsunami, and it is also one of the most important nesting sites of the globally endangered gained leatherback sea turtle. The project is being pushed through with great haste without any environmental impact assessment. Niti Aayog has close come out with a similar plan for the Great Nicobar Island. This area is a biodiversity hotspot. We can learn more about this in chapter 3. What should be done to restore the ecological balance of the Andaman and Nicobar Islands? Implement strictly the orders of the Supreme Court. Help the Jarvas and other tribes maintain their population and culture, even while helping them join modern society. Protect the mangroves and coral reefs, which will protect the islands when the next big cyclone or tsunami occurs. Abandon Niti Aayog's development plans for the islands. Let us now turn to the basic concepts of ecological system or ecosystems. We begin with some important definitions and explanations and then go on to define an ecosystem. Organism, any living being. Examples bacterium, ant, dog, human being, tiger, elephant, whale, plant, tree. Species, a species is a group of similar organisms. Examples human being, dog, lion, elephant, neem trees. What characterizes a species? A species is a clearly identifiable group. The members resemble one another in appearance and behavior. In general, only members of the same species can interbreed and produce offspring that survive and reproduce. Members across species cannot usually produce fertile offspring. Members of a species living in one area may look slightly different from members of the same species living elsewhere. Every organism is a member of a specific species. Each species is given a scientific name. For example, human beings belong to the species Homo sapiens, dogs to Canis familiaris, and neem trees to Agarthrachta indica. Population. A population is a group of individual members of the same species living in a given area at the same time. Examples: frogs in a pond, a colony of ants in a garden, a group of whales moving together in one area of the ocean, oak trees in a forest. What characterizes a population? A member of a species rarely lives alone. Members live together in an area, reproduce, and create a population. Members of a population use common resources. The population is regulated by the same natural phenomena. The size of the population is vital for the survival of the species. A small population runs the risk of going extinct. Community. A community consists of the population of different species, plants, animals, and microorganisms living and interacting in a given area at a given time. Examples of communities: squirrels, deer, owls, bears, bushes, and trees living in a given area of a forest. A lake, aquatic plants, fishes, frogs, and crocodiles living in a particular lake. What characterizes a community? The species in a community interact in various ways. One species may eat another but will rarely exterminate the other. Interactions among species in a community. The species in a community interact in three main ways: predation, symbiosis, and competition. Predation. Animals eat plants and animals eat other animals. Over generations, predators develop strategies for greater efficiency in catching their prey. Their prey, too, develops defense mechanisms to protect itself. Symbiosis refers to an intimate relationship between two or more species in a community. There are three categories of symbiotic relationships: mutualism, both species benefit and they thus rely on each other for survival. Example: nitrogen fixing bacteria living in the roots of legumes provide nitrogen to the plants while the plants supply sugar to the bacteria. Mycorrhiza is the name of the mutualistic relationship between fungi and the roots of 80% of plants. The fungus absorbs minerals from the soil and gives them to the plant. The plant, in turn, provides food to the fungus. Parasitism. One species parasite benefits at the expense of another species host. The parasite gets its food from the host, hence weakening it. In rare cases, the parasite may kill the host. Example 1: more than 100 parasites live in or on our bodies without killing us. Example 2: some mites seems to kill their hosts, the honeybees. Commensalism. One species benefits from the relationship and the other is neither helped nor harmed. Example 1: silverfish moves with the armies of ants, sharing the food caught by the ants. The ants receive neither benefit nor harm from the silverfish. Example 2: small species such as live moss attached to the bark of a tree. Such epithets use the other plant only for physical support. They receive nutrients and water from air, rain, leaves, or other organic debris. The host tree remains unaffected. Competition refers to the interaction between two or more species that seek the same resource for survival. Competition usually harms the weaker competitors. Example 1: human beings compete with many other species for food, space, and other resources. Example 2: birds of different species feed on the same tree. We are now in a position to define an ecosystem. Ecosystem One or more communities of different species interacting with one another and with their non living environment. Examples: a pond, a garden, a hill, a forest, the Himalayas, the Arctic. What characterizes an ecosystem? Each ecosystem has a unique and cyclic climate. Ecosystems contain biological diversity, that is, a variety of animals, plants, and microorganisms. The components of an ecosystem depend on one another, directly or indirectly. Each ecosystem has the feeding hatchery: species A eats species B, which eats species C, etc. There is a constant exchange of matter and energy in any stable ecosystem. There are countless ecosystems on Earth, from the very small to the very big. What is a biome? A biome is a terrestrial and regional ecosystem with a distinct climate and a distinct biological community of plants, animals, and other organisms. Examples: forest, grassland, tundra, desert, mountain. What characterizes a biome? The organism in a biome have adapted to the conditions of the region. A biome is marked by a predominant type of vegetation. What is an aquatic life zone? The equivalent of terrestrial biome is called an aquatic life zone. The two major categories of aquatic life zones are freshwater life zones, ponds, lakes, rivers, streams, etc. Marine and saltwater life zones, oceans, salty lakes, etc. What is the biosphere? The biosphere is that part of the earth where life exists, and it includes troposphere, which is a part of the atmosphere; hydrosphere, surface water and groundwater; lithosphere, soil, rocks, sediments, etc., where life is found. The earth spheres. The earth is essentially land, water, organisms, and air. Thus, the earth as an ecosystem consists of four subsystems or spheres. Lithosphere land. The lithosphere contains the solid land of the planet's crust surface, the semi solid land underneath the crust, and the liquid and near the Earth's center. Hydrosphere water. The hydrosphere contains all the planet's solid, liquid, and gaseous water. Biosphere organisms. The biosphere contains all the planet's living organisms. Atmosphere air. The atmosphere contains all the air in Earth's system. The four spheres are overlapping subsystems. Solid items are found in water, organisms in all the other three spheres, and so on. The atmosphere is divided into different layers or spheres. Troposphere, this is the lowest atmospheric layer and is about 11 km thick. It contains most of the clouds. Stratosphere, the stratosphere extends from 11 to 48 kilometers above the Earth's surface. It includes the ozone layer, which absorbs most of the harmful ultraviolet radiation from the sun. Mesosphere, the mesosphere is above the stratosphere. Here, the atmosphere is very thin. Thermosphere, the thermosphere begins at about 55 kilometers above the earth, is very hot, thousands of degrees. Exosphere, the exosphere is the region beyond the thermosphere. Ionosphere, the ionosphere overlaps the other atmospheric layer. It is that part of the atmosphere ionized by the sun's ultraviolet light and extends from 60 to 1000 kilometers above the earth. Often the biosphere is defined as that part of the earth where life exists. Then it will include the lithosphere, hydrosphere, and troposphere, which is a part of the atmosphere. Levels of organisms in nature: organism, a living being; species, a group of similar organization; population, a group of individual members of the same species living in a given area at the same time; community, population of different species, plants, animals, and microorganisms living and interacting in a given area at a given time. Ecosystem, One or more communities of different species interacting with one another and which their non-living environment. Biome, regional ecosystem with a distinct climate and a distinct biological community of plants, animals, and other organisms. Biosphere, the part of the earth where life exists. What is the structure of an ecosystem? An ecosystem consists of two main components, biotic living part and abiotic non living conditions. The biotic part of an ecosystem includes all the living organisms present in it, plants, animals, and microorganisms. The abiotic part consists of all the conditions under which the organisms live in terrestrial ecosystems. These conditions include water, air, soil, nutrients, minerals, sunlight, temperature, wind, rainfall, geographical location, and other such factors. In aquatic ecosystem, the abiotic conditions include the depth, turbidity level, currents, suspended solids, etc. What is a food chain? Every organism must eat some other organism in order to survive. A food chain is a sequence of organisms in which each one preys on the preceding one. The food chain shows the predator prey relationships. Example 1, grasshopper, mouse, snake, hawk. Example 2, a plant grows and gives seeds. A mouse eats those seeds. A fox catches the mouse and eats it. An eagle pounces on the fox and consumes it. Example 3, diatom, crustacean, herring. The fish species herring eats tiny crustaceans such as crabs, lobsters, and shrimp. And the crustaceans eat diatoms which are allied. What is a food web? In nature, food chains interest in many ways since one species eat many different species and also gets eaten by many other species. Thus, we have food webs, which are networks of interconnected food chains. Example of a food web, you can look pictures on Google also. What is the importance of food chains and food webs? Food chains and food webs shows that living beings are interconnected and interdependent. There is a complex flow of matter and energy on earth. Where do all food chains begin? If every organism must eat another organism to survive, where does the food chain begin? There must be some organisms which can produce their food. Green plants can do so, and hence they are called producers. The plants are eaten by other organisms, which in turn are consumed by yet other organisms, and thus the food chains and food webs develop. A producer is any organism that can convert inorganic matter into food. Producers are thus the foundation of food webs. They make food through a process called photosynthesis. What is photosynthesis? Photosynthesis is the process in which plants use sunlight to combine carbon dioxide and water to produce oxygen. Carbohydrates, glucose, and other nutrients. Plants take energy from the sun, CO2 from the atmospheric through the leaves, and water from the soil through the roots. Photosynthesis is facilitated by chlorophyll, the green pigment in plants. Chlorophyll contains magnesium, which enables plants to convert light into energy. The process can be described as below: carbon dioxide, water, solar energy, carbohydrates plus oxygen. Here, carbon dioxide plus water plus solar energy equal to or make happens carbohydrates plus oxygen. What is the importance of photosynthesis? It is the ultimate source of life and energy for all organisms. The oxygen that produces is vital for human beings and animals. Does photosynthesis take place in aquatic life zones too? Light and nutrients are needed for photosynthesis, and both are scarce in the deep ocean. Thus, the process can only occur in the ocean's upper layers within about 75 meters of the surface. It happens in freshwater bodies too. In addition, a different process called chemosynthesis occurs in the deep ocean where there is no sunlight. In place of solar energy, chemicals are used as the energy source. The process occurs around hydrothermal vents, which are hot springs produced by underwater volcanoes. Green sulfur bacteria can combine hydrogen sulfide, carbon dioxide, and oxygen to make glucose and sulfur compounds at these vents. The process can be described as carbon dioxide plus hydrogen sulfide plus oxygen gives us glucose plus sulfur compounds. What is cell respiration? We saw that plants make glucose and other organisms eat those plants to get energy. Cell respiration is the process in which the molecules of glucose combine with water and oxygen to release energy and create carbon dioxide and water. In a way, cell respiration is the reverse of photosynthesis. We can describe cell respiration in this way: glucose plus oxygen plus water gives us carbon dioxide plus water plus release of energy. What happens in a food chain? At the first level, producers are eaten by organisms called primary consumers. At the next level, secondary consumers eat the primary consumers. Further, tertiary consumers eat the secondary consumers, and so on. Primary consumers, rabbits, goats, etc., which eat plants. Primary consumers, also called herbivores. Secondary consumers, they eat the primary consumers. For example, lions, which eat deer, are secondary consumers. Tertiary consumers, they eat secondary consumers. For example, eagles, which eat snakes, are tertiary consumers. Other consumers could eat tertiary consumers, so the chain goes on. Secondary and tertiary consumers are also called carnivores. There are also omnivores, which eat plants as well as animals. Human beings, bears, and pigs are examples. All consumers also create waste such as fecal matter and animal carcasses. In addition, called decomposers and detritivores, which deal with waste manner. The decomposition of waste matter releases energy, water, carbon dioxide, ammonia, methane, hydrogen sulfide, plant nutrients, nitrogens, phosphorus, and sulfur, and some other organic carbon compounds. What is a decomposer? A decomposer is an organism that digests and breaks down dead organisms and wastes of living organisms. Decomposers are mainly bacteria and fungi. What is a detrivore? A detrivore eats detritus, consisting of organic litter, debris, and dung. Examples of detrivores are flies, cockroaches, crabs, earthworms, snails, wood beetles, and carpenter ants. How can we compare the roles of decomposers and detrivores? Both decomposers and detrivores help in breaking down dead and dying matter. Both of them get their energy from the waste matter. Without their contribution, the earth will be full of dead matter and carcasses. While detrivores eat the waste matter, decomposers secrete enzymes to digest the waste and absorb the resulting molecules. Compared to detrivores, decomposers perform an additional function. In the process of getting their nutrients, they release nutrients from the waste and return them to soil, water, and air for use by producers. What are trophic levels? The trophic levels of an organism is its position in the food chain. The term comes from the Greek word for food or feeding. First trophic level, green plants or producers that make their own food. They are also called autotrophs. Second trophic level, primary consumers or herbivores that eat plants. When we eat fruits or vegetables, we are at this level. Third trophic level, secondary consumers or carnivores that eat herbivores. When we eat meat, we are at the third level. Fourth trophic level, territory consumers that eat carnivores. We are at this level when we eat the fish that eats the smaller fish that eats the algae. All consumers are also called heterotrophs. Omnivores and decomposers fed at more than one trophic level. Actually, the trophic levels are producers, photosynthetic plants, like bacteria. On that, primary consumers, herbivores. On that, secondary consumers, carnivores. On that, territory consumers, top carnivores. Decomposers fed at all levels. Every food web is dependent on all the species in it. If one species, say Y, in the web disappears, then Y is predator X will not get food and will begin to die. On the other hand, the Y is predator will multiply. The entire web will then go out of balance. In the food chain, the top carnivores are in a precarious position. They are small in number and their survival depends on all the species down the chain thriving in their ecosystems. What are ecological pyramids? As we go up the trophical levels, beginning with the producers, we will see a change in ecologically important parameters such as total energy, amount of biomass, and the size of the populations. Ecological pyramids depict this change in the form of diagrams. The term pyramid indicates that the parameters generally reduce in quantity as we move up the trophic levels. Three types of ecological pyramids are most common: pyramid of energy flow, pyramid of numbers, pyramid of biomass. What is the pyramid of energy flow? When a primary consumer eats a producer, it takes energy from the producer. It is a law of nature that when such an energy transfer takes place, a substantial part, about 90% of the energy, is lost at as less useful heat. Again, there is a loss of 90% energy when a secondary consumer eats a primary consumer. Thus, the ecological efficiency of energy transfer from one organism to another is only 10%. Why is there such a loss of energy? As we move up the trophic levels, first, an organism does not digest all the food that it eats. The undigested food does not provide any energy. Second, some energy is used up just in the process of living. Third, energy is always lost when transformed from one form to another. The pyramid of energy flow shows this loss of energy at every level in the food chain. Pyramid of energy flow, heat 9, tertiary consumers 10, heat 90, secondary consumers 100, heat 900, primary consumers 1000, heat 9000, 10,000 units producers 10,000 units. What is the pyramid of numbers? Pyramid of numbers shows that the number of organisms also drops drastically from level to level. Take a simple food chain: plants, grasshoppers, toads, snakes. Many plants are needed to feed a smaller number of grasshoppers. Then the number of toads living off the grasshoppers is much less. The number of snakes in the ecosystem that depends on toads is even less. What is the pyramid of biomass? Pyramid of biomass shows that in general there is a drastic reduction in the dry weight of all the biomass contained in the organisms as we move up the trophic levels. Pyramid of biomass. Territory consumers snakes biomass 10 kg. Secondary consumers toads 100 kg. Primary consumers grasshoppers 1000 kg. Producers grass 10,000 kgs. As we go up the food chain, we lose 90% of biomass at each level due to two reasons. Much of biomass, especially at the first trophic level, never gets eaten and becomes an into the decomposers. Not all the biomass consumed by an organism gets converted into bodily tissue. Some of it is stored in the body to be used when needed. What are inverted ecological pyramids? The energy flow in ecosystem is predictable and can always be shown by an upright pyramid. That is not always the case with numbers and biomass, where there is a direct correlation between energy, numbers, and biomass. We get upright pyramids of numbers and biomass. However, such a correlation is not true of all ecosystems in all times. In the ocean, the total biomass of large and long lived fish could sometimes exceed that of the small and the short lived phytoplankton, which is at a lower trophical level. Again, the pyramid of numbers is always inverted in a parasitic food chain. A single tree may support many parasites, which in turn may help a larger number of hyper parasites. In a forest, a single big tree producer may support a huge number of herbivorous insects consumers. These insects may support a smaller number of carnivorous insects, which in turn may support a much smaller number of birds. In this case, we have a non pyramidal distribution of numbers. Non pyramidal distribution of numbers are tree, herbivorous insects, carnivorous insects, birds. What is ecological succession? Ecological succession is the process by which communities of plant and animal species living in a given area get replaced over time by a series of different communities. This phenomenon is clearly noticeable when barren or denuded land regenerates over time with new species emerging in the community. There are two kinds of ecological successions. Primary ecological succession happens in a barren area without any soil. Imagine a hard rock on a hillside that is not disturbed by any grazing animals. With rain and some bird droppings, the rock is first colonized by lichens, which are both fungi and algae. Lichens secrete an acid that breaks down the rock, which begins soil formation. In such a succession, the lichens would be called pioneer species since they were the first to colonize the area. Pioneer species set the stage for other species to establish themselves in the area. Then, as lichens die, the waste matter adds to the soil. Mosses then arrive and form a mat which traps any soil the wind may bring. When mosses die, more soils gets formed. Soon, seeds dropped by birds start germinating and small plants begin to grow. The bigger plants grow and the previous plants disappear. This kind of succession goes on until a whole forest grows. Of course, this will not happen if, for example, the small plants are eaten up by grazing cattle. Secondary ecological succession occurs in an area in which natural vegetation has been removed or destroyed, say by a fire or a cyclone. The situation is different from the case of primary succession. The soil is still present. Seeds, roots, etc. of plants may also be present. The secondary succession starts with the growth of grasses and weeds. Next, small plants begin to the secondary succession starts with the growth of grasses and weeds. Next, small plants begin to grow, and after that, the sequence is similar to that of the primary succession. But the succession could happen faster compared to primary succession. In either case, the time scale of ecological succession could be decades or longer. After a forest fire, for example, the succession might take place over a couple of decades. After a mass extinction of species, succession might need millions of years. What is a climax ecosystem? As ecological succession continues, a stable state might be reached when the organisms in the ecosystem have adapted themselves best to their abiotic conditions. A climax ecosystem has reached such a steady state. Even a climax ecosystem continues to change, thus, there is no final stable state. Also, a climax system could be disturbed by a drastic change in climate or the arrival of an invasive species. Then, ecological succession starts again. What is a habitat and what is an ecological niche? The habit of a plant or an animal is the area in which the organism or a population of organisms is adapted to live and grow. The habitat is marked by abiotic and abiotic factors of the site, such as climate, vegetation, soil, water, etc. A given area may be the habitat of several species. You might then wonder, how do many species live in the same habitat without competing with and destroying one another? There are, of course, predator prey relationships in a habitat, but rarely do they lead to the extermination of a species. The reason is that in a stable ecosystem, each species has found its ecological niche and it is thus able to coexist with other species. An organism's ecological niche consists of all the physical, chemical, and biological conditions it needs to live in the habitat. The niche includes the organism's food habits, ways of nesting, and reproduction, etc. For example, in a forest, different species thrive to varying heights without competing with one another. A vulture eats the carcass, but what it leaves behind become food for many tiny organisms and decomposers. We can distinguish between fundamental niche and realized niche. For a species, the fundamental niche is the ideal set of conditions in which it can thrive without competition or predators. The realized niche is that part of the fundamental niche that the organism can enjoy. What is a home range? Home range is where an organism lives and finds what it needs to survive. The organism regularly moves about in its home range. We can think of home range as the organism's territory, which it will defend against encroachers. What is the difference between habitat and home range? While habitat is defined by all the biotic and abiotic conditions in which an organism lives, home range is purely the geographical area in which it resides. What is meant by ecotone and edge effect? Consider a beach where exact does the land and the sea begin. It is difficult to draw such boundary line because tides come in and go back over the day and over seasons. Again, think about a forest, which is the border between forest and non-forest. It is difficult to fix the dividing line because the forest gradually thins out and we begin to see the non-forest land. The transitional zone between two or more adjacent ecosystems is called an ecotone. What characterizes an ecotone? In most cases, an ecotone cannot be clearly defined and marked. Often, an ecotone contains species not found in the adjacent ecosystems. In other words, an ecotone is marked by richer biodiversity compared to the bordering ecosystems. We call such an occurrence of greater biodiversity as the edge effect. The ecotone usually contains unique species and ecological relationships. We can see the edge effect clearly in coastal zones which contain expectational levels of biodiversity. What do we mean by the productive of an ecosystem? The productivity of an ecosystem is measured by the rate of generation of biomass in it. Productivity is usually expressed in units of mass per unit surface or volume per unit time. For example, the unit could be grams per square meter per day. Productivity can also be measured in kilocalories of energy produced per square kilometers per day. We can compare the productivity of different ecosystems. Take, for example, a piece of grassland, a lake, mangrove forest, and the ocean. The productivity goes up as we move along this sequence of ecosystems. For the same volume, a lake produces more life and biomass than a grassland does. A mangrove forest, the nursery for many fish species, is more productive than a lake. Some parts of the ocean are much more productive than the mangroves. We can also think of the productivity of an organism. For example, the amount of biomass that a plant grows per day. For the pyramid of biomass, it is clear that productivity goes down rapidly as we move up the trophic level. Primary productivity is that of the autotrophs or producers that make food through photosynthesis. Secondary productivity is that of all consumers who grow biomass in themselves by eating producers or other consumers. What are cycles and ecosystems? The earth is open to receiving solar radiation, but it is virtually a closed system as far as matter is concerned. Thus, the substances essential for life, such as water, carbon, oxygen, nitrogen, and phosphorus, are present on Earth only in fixed quantities. We cannot make more of them. Nature, however, makes sure that all living beings get what they want by continuously recycling the substances. These cycles are called biochemical cycles because they involve biological, geological, and chemical process. The three types of biogeochemical cycles with examples are given below. Hydrologic cycle, water cycle, gaseous cycles, carbon cycle, nitrogen cycle, oxygen cycle, sedimentary cycles, phosphorus cycle, sulfur cycle. The water cycle can also be considered to be a gaseous cycle. Human beings have the power to either support or harm the recycling process. Over the last 2 centuries, we have been busy disrupting and disturbing the cycles through our activities. This disruption will only rebound on us in the form of climate change and other such catastrophes. What is the water cycle? The main process in the water cycle are water evaporates from the ocean, lakes, rivers, ponds, etc. Plants extract water from the soil and some of it evaporates through the leaves. Wind and air move the water vapor through the atmosphere. The water vapor becomes a cloud and the precipitation falls back partly on the ocean and partly on land. The water that falls on land percolates through the soil and gets stored as groundwater. Some of it flows into the ocean, rivers, and other water bodies. The cycle starts again. We can see water cycle pictures on Google too. What is the importance of the water cycle? It converts the salt water of the ocean into potable fresh water. It provides us with fresh water every year in the form of rain. What is the carbon cycle? Carbon is essential for cells. Most of the carbons on Earth is stored in rocks. The rest is in the ocean atmosphere, plants, soil, and fossil fuels. The main processes in the carbon cycle are during photosynthesis, producers take in carbon dioxide and release oxygen into the atmosphere. Human beings and animals breathe in oxygen and release carbon dioxide, which goes back to the plants. Decomposers break down decaying organic matter and, in the process, release carbon dioxide into the atmosphere. When volcanoes erupt or a forest fire occurs, more carbon dioxide enters the atmosphere. Cattle give out a lot of methane, also a carbon compound. The ocean absorbs as well as releases carbon dioxide. To these natural processes, human beings have added another process. When we burn fossil fuels, which are stored carbon, we release carbon dioxide into the atmospheres. Carbon cycle, photosynthesis, atmospheric carbon dioxide, producers, plants, trees, consumers, decomposers, soils, combustion, coal, oil, etc., respiration. In addition to this cycle, there is a much slower one in which carbon moves between rock, soil, ocean, and atmosphere. Nature always strives to keep the carbon cycle in balance to keep ecosystems going. However, excessive emissions from human activities have sharply increased the amount of carbon in the atmosphere. These emissions have led to global warming and climate change. What is the nitrogen cycle? Nitrogen is required for cells to build their proteins and genes. Most of the nitrogen on Earth is in the atmosphere as gas. Living organisms need nitrogen but cannot absorb it directly. The complex nitrogen cycle converts nitrogen into forms such as ammonia that organisms can absorb. This process is called nitrogen fixation, which is carried out by bacteria. These bacteria live in the roots of leguminous plants such as the bean family. The main processes in the nitrogen cycle are plant bacteria take nitrogen from the soil and produce ammonia. Other bacteria turn ammonia into ammonium nitrate, which is absorbed by green plants. Legumes and the bacteria in them enrich the soil with the nitrates. When plants die or they shed leaves, flowers, etc., the decomposers release ammonia. Excreta and urine of animals also enrich the soil with nitrogen. Other denitrifying bacteria break down the nitrates into nitrogen, which returns to the atmosphere. Nitrogen cycle. We can see more pictures from Google too. What is the phosphorus cycle? Phosphorus provides material for cell membranes, genes, teeth, and bones. It is a main ingredient in fertilizers. The main process processes in the phosphorus cycle are phosphorus compounds leach out of rocks over a long period. The compounds are taken in by producers from whom it goes to the consumers. When organisms decompose, the phosphorus goes back to the soil. We mine phosphates for making fertilizer and detergents. Fertilizer runoff and detergents in wastewater reach rivers and ultimately the ocean. Excessive phosphates led to the explosive growth of algae and the ecosystem stability is affected. Phosphorus cycle. There are other cycles too, such as the sulfur cycle, soil cycle, oxygen cycle, potassium cycle, and calcium cycle. What is the importance of biogeochemical cycles? Biogeochemical cycles regulate the flow of substances to where they are needed, link through their flow the biotic and the abiotic components of ecosystems, enable the transformation of substances from one form to another, enable the movement of essential substances from one part of the biosphere to another, store substances in reservoirs and release them in consumable doses. What are ecosystem services? Ecosystem services are the benefits people obtain from ecosystems. These are the services nature has always provided to all living beings virtually free of cost. Instead of valuing them, we take them for granted. There are four kinds of ecosystem services: provisioning services such as food and water, regulating services such as flood and disease control, cultural services such as spiritual, recreational, and cultural benefits, supporting services such as nutrient cycling that maintain the conditions conditions for life on earth, provis- uh, provisioning services from ecosystems. These are the products obtained from ecosystems including food, plants, animals, etc. Fiber, wood, jute, etc. Fuel, wood, dung, etc. Genetic resources used in breeding and biotechnology. Biochemicals, natural medicines, and pharmaceuticals. Ornamental resources such as skins, shells, and flowers. Fresh water. Regulating services from ecosystems. These are the benefits obtained from the regulation of ecosystem processes, including air quality maintenance. Ecosystems both contribute chemicals to and extract chemicals from the atmosphere, influencing many aspects of air quality. Climate regulation, affecting both temperature and precipitation, sequestering or emitting greenhouse gases. Water regulation, erosion control, water purification and waste treatment, regulation of human diseases, biological control of pests and diseases, pollination, storm protection by mangroves and coral reefs. Cultural services from ecosystems. These are the non material benefits people obtain from ecosystem through spiritual enrichment, cognitive development, reflection, recreation, and aesthetic experiences, including spiritual and religious values, knowledge system, traditional and formal, educational values, inspiration for art, folklore, etc., beauty and aesthetic values, cultural heritage values, recreation, and ecotourism. Cultural services are tightly bound on human values and behavior, as well as to human institutions and patterns of social economic, and political organization. This precipitation of a cultural services are more likely to differ among individuals and communities than, say, perceptions of the importance of food production. Supporting services from ecosystems. Supporting a services are necessary for the production of all other ecosystem services. They differ from provisioning, regulating, and cultural services in that their impacts on people are either indirect or occur over a very long time. In contrast, changes in the other categories have related direct and short term effects on people. For example, humans do not directly use soil formation services, although changes in this process would indirectly affect people by impacting the provisioning service of food production. Examples of supporting services: erosion control, soil formation, primary production, production of oxygen through photosynthesis, nutrient cycling, water cycling, crop pollination. Some services like erosion control can be categorized as both a supporting and a regulating service depending on the time scale and immediacy of their impact on people. What is the state of the planet's ecosystem? A significant study of world's ecosystems was the Millennium Ecosystem Assessment (MA), initiated by the UN in 2001 and completed in 2005. The objective of MA was to assess the consequence of ecosystem change for human well-being and the scientific basis for action needed to enhance the conservation and sustainable use of those systems and their contribution to human well-being. About 1400 scientists were involved in the study. Millennium Ecosystem Assessment. The main findings: over the second half of the 20th century, we made unprecedented changes to ecosystems to meet our growing demands for food, fresh water, fiber, and energy. These changes have weakened nature's ability to deliver other vital services such as purification of air and water, protection from disasters, and the provision of medicines. Human activities have taken the planet to the edge of a massive wave of species extinctions. The loss of ecosystem service is a significant barrier in our attempts to reduce poverty, hunger, and disease. The degradation of ecosystem could grow significantly worse during the first half of the 21st century. We can reverse the degradation of ecosystem to some extent, but we have to make fundamental changes in our activities. Such changes are not happening now. What is the UN Decade on Ecosystem Restoration 2021 to 2030? On March 1, 2019, the UN General Assembly declared the Decade on Ecosystem Restoration 2021 to 2030, a rallying call for the protection and revival of ecosystems worldwide for the benefit of people and nature. It aims to halt the degradation of ecosystems and restore them to achieve global goals. Only with healthy ecosystems can we enhance people's livelihoods, counteract climate change, and stop the collapse of biodiversity. The decade aims to massively scale up the restoration of degraded and destroyed ecosystems as a proven measures to fight the climate crisis and enhance food security, water supply, and biodiversity. The UN decade is building a strong, broad based global movement to ramp up restoration and put the world on track for a substantial future. It runs from 2021 through 2030. The timeline scientists have identified as the last chance to prevent catastrophic climate change. 2030 is also the deadline for achieving the Sustainable Development Goals. In September 2021, the UN released 10 principles to guide restoration initiatives during the decade. Global contribution, broad engagement, continuum of activities, benefits of nature and people, addressing causes of degradation, knowledge integration, measurable goals, local and land sea scale contexts, monitoring and management, policy integration. UN, FAO, and UNEP are leading the implementations of the decade. What is ecological balance and is it being disturbed today? In this chapter, we have seen enough evidence to show that the organisms in an ecosystem are profoundly interdependent and also dependent on the abiotic conditions. No organism by itself can produce all the food it needs and decompose all the waste it creates. Even an autotroph needs water and sunlight. Many species can exist only in a symbiotic relationship with another. Thus, for an ecosystem to remain stable and for all its organisms to survive and prosper, there should be an ecological balance between its biota and the abiotic condition. The biosphere should also be in a state of ecological balance that is vital for all living beings, including humans. As we saw in chapter 1, however, human activities are seriously threatening the global ecological balance. This is true of India's ecological balance too. In the subsequent chapters, we will elaborate on the crisis and discuss solutions being attempted in India and the rest of the world. What is unique about human beings and how has that feature affected ecosystems? The human species is almost the only one that exterminates other species. Human beings have well developed brains that have helped them increase their power enormously through science and technology. Human beings have come to believe that they are a superior species and have the right to take whatever they want from nature without any limit. All these have led to the over exploitation of ecosystems and brought about a crisis. What should you remember from this chapter? Write down the following each on a flashcard for a quick revision later. Whenever relevant, write down examples and what characterizes the factor or process. Definition, explanation of all keywords and phrases such as ecosystem, photosynthesis, decomposition, trophic levels, ecological succession, ecological pyramids, habitat, ecological niche, ecotone, and age effect. Comparison of decomposers and detrivores. Trophic levels and ecological pyramids draw the diagrams. Definition of productivity of an ecosystem. Biogeochemical cycles in nature and their importance, in particular the carbon and water cycles, draw the diagrams. Ecosystem services types, examples of each type, explanation of ecological balance. Remember also the facts. The ecology of the Andaman and Nicobar Islands is being destroyed by deforestation, overfishing, pollution, and development projects. The Millennium Ecosystem Assessment 2005 found that we had made unprecedented changes to ecosystems to meet our growing demands for food, fresh water, fiber, and energy. What must be done to save the ecosystems of the planet? Reverse the degradation of the planet's ecosystem by reducing our impact on them. Thank you.